As digital image processing developed in the 1970s, this allowed for greater innovation in the area of computer vision. Research in many areas of computer vision took place and new algorithms were developed, such as pictorial structures, optical flow, and line labeling algorithms. By 1977, the Tsukubu mechanical was yet another milestone in autonomous vehicle driving. This Japanese-based mechanical engineering lab produced an autonomous passenger vehicle that used analog computers and two mounted cameras to detect and recognize white street markings. This vehicle, which is considered to be the first world's autonomous car, could reach speeds of 20 miles per hour. In the 1980s, quantitative image and scene analysis gave way for improvement on the Tsukubu mechanical. In 1986, the Pan-European Prometheus project began. Lasting until 1994, the Prometheus project remains the largest autonomous vehicle project ever funded. This project consisted of 12 demonstrated projects ranging from vision enhancement to collision avoidance. Also, in 1986, a German engineer, Ernst Dickmanns, and his team from the University of Bundeswehr, Munich, retrofitted a regular sedan with an array of cameras and 60 microprocessing modules. Relying on saccadic vision, Kalman filters, and parallel computers, Dickman's system could detect objects on the road, both behind and in front of the vehicle. He called his system Vamors and said that the most important object of his project was dynamic vision. His imaging system was able to filter out noise and focus only on the object it was meant to focus on, exactly like a Gaussian filter. The Vamors proved to be very successful as it maneuvered Germany's Autobahn at a high speed of 60 miles per hour. As research and development in computer vision continued, the 21st century brought new feature-based recognition and interactive tone mapping algorithms. In order to further technological development and spark innovation in the autonomous vehicle field, in 2004, the Defense Advanced Research Projects Agency, or DARPA, funded the DARPA Grand Challenge. Since then, the challenge has taken place annually with a cash prize being awarded to the winner. In the inaugural year, the challenge required an autonomous vehicle complete a 150-mile route in the Mojave Desert, with the best car reaching 7.32 miles. No car completed the race. The following year, out of 23 contestants, all but one failed to reach the previous year's best of 7.23 miles, with 5 vehicles completing the entire race. Since then, the competition has evolved. In 2007, the Urban Challenge was held. This took place in a simulated urban environment and required vehicles to obey traffic regulations and successfully interact with other vehicles and obstacles. In just 1 year, the DARPA Grand Challenge achieved its goal of innovation in the field of autonomous vehicles.
One of the most interesting and intriguing systems today is Tesla's autopilot. This semi-autonomous feature enabled drivers the option to drive hands-free on large highway and freeway systems. With the use of only 8 cameras, 12 ultrasonic sensors, and one forward-facing ARS or advanced radar system, Tesla developed the software to drive their vehicles hands-free. Many people don't realize that Tesla is still in the developmental phase of producing fully autonomous vehicles, and what they currently have is only semi-autonomous software. Tesla has needed to increase their processing power with over 40 times the computing power of their previous generations. This has enabled them to run their vision, sonar, and radar systems simultaneously for safer, semi-autonomous driving. With the given hardware on their vehicles, Tesla is able to drive completely autonomously, however, their software lags behind. Tesla is currently creating software for their vehicles to drive fully autonomous, which can be flashed onto the vehicle hardware over the air.
AutoX is a small company founded by former Princeton professor Jianjing Zhao. Dr. Zhao and his team have created a computer vision system that relies totally on cameras. Unlike Tesla and Google, AutoX's design does not have radar, LiDAR, or ultrasonic sensors. AutoX has retrofitted a Lincoln MKZ with 7 $50 Best Buy cameras, and they have successfully tested their design. AutoX's goal is to provide this technology to just about everyone, and they plan to add LiDAR to its design once it's more affordable. AutoX does not plan on